Hello guys, welcome back to the channel. So in this today's video we'll be solving the Leetcode question number 17, letter combinations of a phone number. So first let's read the question. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that number could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. So here 1 and 0 does not map to any letters. So there is only mapping from 2 to 9 inclusively. Let's see how to solve this problem. So whenever you encounter this kind of combinations and permutations problem, you supposed to visualize in the form of tree, binary tree or any n-array tree, then the half of the problem will be solved. Let's see how to solve this problem using like visualizing the tree. So first let's take the first example. Let's take first 2 3. So this is the 0th level. We have empty string. So first number is 2. So from this 2 we can start string with any three of these letters A, B, C. So A, B, C. So now 2 is done. You can cross it out. So next number is 3. In 3 we have D, E, F. We can map each of the letters from 3 to this graph. So that means A will be mapping to 3 letters from 3. So it will become AD, AE, AF. So again from B also BD, BE, BF. From C, CD, CE, CF. So this is the solution that these are the possible combinations of 2-digit number. Now let's increase one more number. Let's take 2 3 4. 3 completed. Again 4 we have G, H, I. So here again the tree grows in the form of n power n. A, D, G, A, D, H, A, D, I. So like this tree grows. You need to call this process recursively until all numbers gets completed. So at the end of every base call you need to store the results. Now let's see the time complexity for this solution. So if we take this is the 0th level, this is the first level, this is second level, and this is third level. So here, so it will become 3 power 1, that means 3 outputs we got. So here 3 square, here we got 9 outputs, here 3 cube. In this level 3 we got 27 outputs. Here you can see in the 9, in the keypad we have 4 letters W, X, Y, Z. So in the worst case the string will become length is 4. So it is 4 power n in the worst case if the string starts with the letter 9, the number. So and again at every stage you generate a one n string output that you need to map and store it in the results. It will take n time to concatenate all digits in it from the tree. So the total time complexity will be n into 4 power n. Now we will see how to solve this problem with using the recursion in Python as well as Java. Okay, now let's write code in Python. Here I already created the one empty dictionary which contains all mapping letters. So first we have to check for base case. If digits equal to empty, that means you have to return empty array back. Now capturing the length equal to length of digits creating one empty array to store the results. Now let's create a function, DFS depth first search function, which takes the two arguments. One is position and another one is string, to track the combination of the string over the recursive calls. So if the position equal to length, it's better to create this function inside the function. If it is equal to length, then we supposed to append it to the result dot string. Else, that means still some more positions are left, we need to map to the previous string. So in that case, extract the letters from phone. So the position which we are going to extract is digits of position. So we get the position from the we have the current position. With that position, we find the which digit we are going to mapping next. We take that digit and we cross check with the phone dictionary. Then we take out those letters and we iterate through all letters, and we make a recursive DFS call for I in letters DFS. Now we need to increment one position, then add it to the existing string. So then finally call this function DFS starting with 0 position and with empty string, then finally return the result. So now let's write code in Java. Here already created one hash map and inserted the required values into it. Now first we have to check the base case. If digits equal to null or digits dot length equal to 0, return one empty array list. Now let's create the main DFS function. So first private void DFS. So first we pass the position that we used to find like where we are in the digits. Next string of digits. Next string builder. Next the result, list of string result. Then finally map of character and string. Yep. So we are taking the 1, 2, 3, 4, 5 arguments. Now first we need to check the base condition. If position equal to digits dot length, we supposed to add it to the result, that string that we traced back, or the recursive calls result dot add str dot to string, then return. Else you need to take the current position from the digits and get the with that digit get the information from the map phone dictionary, take those letters and iterate over those letters, and again call this recursive call DFS recursively. So for that string temp, let's say letters equal to map dot get digits dot caret of position. For int I equal to 0, I less than letters dot length I plus plus. Now you need to add this string, like add the current take each letter and add it to the string and call the DFS call. So string dot string dot append letters dot caret I. Now call this DFS function recursively, and DFS increase one position digits on the string, next result, then map. Now decrease the string length, str dot set length, str dot length -1. Now it's pretty much for this function. It's almost completed. Now we supposed to call this function in the main function, list of string result equal to new array list. Call this DFS function, start with 0, next digits, initialize new string builder, then result, then map phone dictionary, return result. Thank you guys. I will see you in the next video.